Hello, dear student. How are you? I hope you all will be fine. I'm also fine. Thank you. How is the study going? I hope it will be fine. It will be clear. Okay, thank you. Today is the lecture number 12 of Crystal Field Theory, and today lecture we will be studying about crystal field theory. The topic in crystal field theory as crystal field stabilization energy for tetrahedral complex. How someone can calculate crystal field stabilization energy for tetrahedral complex. In last previous three lecture I already told, in last previous two lecture I delivered. I told you about tetrahedral, how is the tetrahedral complex splitting in tetrahedral complex occur. And so here today lecture we will be seeing about a crystal field stabilization energy, that how much tetrahedral complex are stabilized by splitting of d orbital. Let's suppose this is d orbital. This d orbital. It's split into T2G and T2 sets and E sets. This is E sets, where E sets are lower in energy while T2 sets are higher in energy. So here there is dxy. This is, let's suppose this is xy, this is xz, this is yz, dxy, dxz, dyz. This is of d T2, this of d, while this of d, this is x square minus y square, and this is z square. So if let's suppose this is the normal, this is the normal. So that E energy, the energy of E sets as a decreased, as a decrease down. This is the amount of minus 0.6 del naught delta t decrease. This is 0.6 delta t decrease, while the energy of T2 sets are increased. This is 0.4 delta naught delta T time increased. The energy of T2 is increased by 0.4 delta T, while the energy of E set decreased by 0.6 delta T. Is it clear? Also, 1 delta T is equal to 0.6 plus 0.45 delta naught, means 0.45 delta naught is equal to 1 delta naught. It also means that delta t will be always less than delta naught, or you can say that 1 delta naught will be equal to 1 divided by 0.45 delta t. Mean if we divide delta t by 0.45, so this will be equal to 1 delta naught, means delta t will be decreased by 1 divided by 0.45 times then delta naught. Is it clear? So we can say that 0.45 delta t is equal to 0.18 delta naught. Also 0.6 delta t is equal to, or minus 0.6 delta t is equal to minus 0.27 delta naught. Is it clear? Okay, so it means that the E set has energy decreased by minus 0.27 delta naught or 0.6 delta t, or you can say that the T2 set has energy increased by amount of 0.4 delta t or by amount of 0.18 delta naught. Is that clear? So you can say that the T2 set has, if we you can calculate the in energies that stabilize the system, the decreasing in energy, that's called crystal field stabilization energy. The energy that decrease the system, that decrease the energy of the system, can be calculated by decrease in energy, decrease in energy due to decrease in energy of due to E set plus plus increase in energy, increase in energy due to T2 set. Is it clear? So increase decrease in energy of E set will be equal to, it will be equal to decrease in energy of E set, so it will decrease in energy of E set will be equal to 0 minus 0.27 delta naught. So, and increase in energy due to T set is equal to 0.18 delta naught, sorry, 0.1 delta naught multiply by P, because if number of electron is present, P is the number of electron in E set, plus increase in energy due to T2 set, which is 0.18 delta naught multiplied by Q. So you can also write that this equation is like that, the minus 0.27 P plus 0.18 Q and 2 delta naught. Is it clear? Also you can write the equation in this form. This is minus 0.27 P, let to correct the board position. Okay, 0.27 P plus 0.18 Q and 2 10 dq, 10 dq, because 1 delta naught is equal to 10 dq, so we put instead of delta naught 10 dq. So we can write this equation like that, that minus 2.7 P plus 1.8 Q dq. So this is the crystal field stabilization energy in different form. Is that clear? You can calculate crystal field stabilization energy for any system, for any system in the form of delta, crystal field stabilization energy in the form of delta naught as well as in the form of delta T, in the form of delta Q. But crystal field theory cannot be apply for here. We cannot put the mean pairing energy, because in we cannot get the equation for tetrahedral complexes in the form of mean pairing energy, because in mean pairing energy is used when the electron paired against electron repulsion. But here only high spin complex is available, not low spin complex, while mean pairing energy is applicable for low spin complex. So here is high spin complex only used, that's why here we cannot put melting sorry mean pairing energy. Okay, is that clear? You can also take example on this formula, and that is the today topic. Is that clear? You can also take screenshot. I hope you will be get clear to the, this is lecture number 12. So in lecture number 13, in next lecture we will be studied about the another application of crystal field theory, that how crystal field theory is applicable for tetragonal complexes as well as for square complexes. So there are only few lectures, 2 or 3 lectures remaining in crystal field theory. After that crystal field theory will be cleared completely. Okay, thank you, best of luck. I hope you will be cleared, your concept will be for make made. If you have any problem, if you have any question, if you have any misunderstanding, you can ask me in comment section, or also you can ask me in private in WhatsApp. I put my WhatsApp number on the video thumbnail. Okay, thank you. Best of luck. Please subscribe my channel. It help me. It make me feel happy. Thank you. Best of luck.